Hello, ladies and gentlemen, and welcome back. In this video, we're looking at our second question, question number 2, from the Euclid contest, the 2011 paper that we started last time. So just like question 1, we have 2 light bulbs and a written. This is pretty standard for the first 2 questions. And then 3, 4, 5, 6, and usually 7 only have 2 parts, 1 light bulb, 1 written. That tends to be how it goes, so it's usually what you can expect. All right, 2A. An equilateral triangle of side length 1 is cut out of the middle of each side of a square of side length 3 as shown. What is the perimeter of the resulting figure? Okay, well, we can sort of draw our square here. Now, it's side length 3, but we come along, we cut out an equilateral triangle of side length 1, so all these sides here are 1. Now we lose 1 here. We still have 1 and 1, and these sides here are 1. So we get 4 along this side. And you'll notice that the same thing happens on every other side. We have 4 of these length 1 segments. So if one side is 4, and we've got 4 sides to our square, we should have 4 times 4, or 16. So 16 is our perimeter. It's a light bulb question, so we just need to write perimeter. But if you want to show a little work, I mean, you could even just number all of these if you want. Okay, and that would be perfectly fine. We get 16 for our perimeter. All right. B part. In the diagram, DC is equal to DB. They've got that shown with these nice little lines here, these tick marks. Angle DCB is 15 degrees. Well, it's isosceles, so this is going to have to be 15. And we also know that angle ADB here is 130 degrees. What is the measure of ADC? This one over here. Okay. So we draw a copy of our picture. Little isosceles. Now we're told we get 15 here, and as I mentioned, isosceles triangles, the angles opposite the equal sides must themselves be equal. So now I can understand every angle inside this triangle. I've got these two, and I know the sum of the angles inside a triangle is 180 degrees, so this must be 180 minus a 15 minus a 15, so 150. We'll mark this in red. This angle here is 150. And what else are we told in the question? Well, we're told this angle over here is 130. 130, 150. And what do we want? We want this angle over here. Well, look at that. We've got ourselves a full circle around this point D. How many degrees in a full circle? Going around the whole point once from start to finish should be 360 degrees. So 360 is 130, the angle we're given, plus 150, the red angle that we found in this triangle, plus the unknown angle that we want to find. So we get our unknown angle is 360 minus 280. And so the angle we're missing is 80. And there we go. Okay, nothing else really to say about that one because it is a light bulb question. If you wanted to, I mean, you probably, if you're going to reference your picture, should probably be having everything nice and labeled, but you don't have to. Oh, I've got those sides wrong. Not that it really matters. Okay, now C part. Here's where we actually have to write down things and be very careful as to what we say, so that everything's clear and it's easy to read. In the diagram, angle EAD is 90 degrees, so is angle ACD, that's this angle here, and ABC. So we've got a bunch of sort of right angle triangles building off of each other, spiraling in around A. We also know ED is 13, EA is 12. Automatically, I know this is going to be 5, because I know my Pythagorean triples. We've got DC is 4. We've also got C down here is 2. We want to know what is AB. Well, this is just going to be a series of Pythagorean triangle and Pythagoras' theorem arguments. I draw my picture. It was E. Everything's spiraling around A. D here. C here. B here. We got 2. We've got 4. 13, 12. Now I do want to write things up. Nice. So we might say by Pythagoras. I know AD squared is, and we can even if we really want to. I mean, you can just write 13 squared minus 12 squared. Everyone's going to know where those are coming from. But if you're worried about it or something, you can say DE squared minus EA squared, and then say 13 squared minus 12 squared. And this is just 5 squared, so we can say AD is 5. If you want to write it out, it's 169 minus 144 is 25. But I'm telling you, you don't have to. People can follow along when they read. So we've got this 5 here. And now we can find AC similarly. And you could also say, by Pythagoras. AC squared is AD squared minus DC squared. 5 squared minus 4 squared. It's going to be 25 minus 16. It's going to be 9, so it's 3 squared. So AC is 3. Okay? And then we could say something like, finally, I'll just draw a copy of this, the smaller triangle again. We had a 2 here, and we just found this 3. Finally, we see AB squared, the thing we want, is AC squared, what we just worked out, minus BC squared. So that'll be 3 squared minus 4 squared, and that will just be 5. Sadly, this is not a nice little Pythagorean triple. But 9 minus 4 is 5. So AB is square root of 5. Put a nice little box or a therefore statement, and we're done. We're good to go there. Okay. So that's question 2 all sewn up. Next up is going to be question number 3. If you'd like to join me for that in the next video, you're more than welcome to. And if you want to give it a try beforehand, I highly recommend it. Practice does make perfect. But I'll see you there.